Hi dear, this is Madan sir here, and I'm here with another video from Electrochemistry. And as you know, I do things in a sequence. So this is going to be the very next topic from the electrochemistry, from where I left. So this time, I'm talking about, the conductance of solid versus conductance of electrolytic solution. This is like, differentiating the conductance of solid with respect to the liquid. Let me take an example. Flow of current through copper wire is an example of conductance through a solid, but flow of electric current through a salt solution is an example of electrolytic conductance, right? So the first thing I'm giving is an example here. Current flowing across a copper wire. This is an example of conductance of solid. Now what right here may be, current flowing through salt solution. This is an example of the electrolytic conductance. What second, thing we can, talk about is that it depends on, number of valence electron per atom of metal. What that means? The conductance of solid depends on electron, and it basically depends on the valence electron. So more the number of valence electron, higher will be conductance of a solid. There it depends on concentration of ions. There it depends on concentration of ions in the solution. So this is what the thing is. There electron flow, and that is responsible for flow of current, but there the ions flow, that is responsible for the conductance of electrolyte. What third thing is that, resistance here, depends on collision between electron flowing towards positive and cations, or I should say metal ions. This is really important. You know what? So far you have studied that resistance is a natural property of wire, which actually cause obstruction in the path of the flow. But what happened? What is the reason of the resistance? You might not know. So there is the reason I am telling you. What happened when the electron flow? I tell you what. Suppose this is a wire here. So there are positive charge here. And there electrons are, there is the positive here net, and there it is negative here. So electrons are moving in this direction. So while they move in this direction, what happens? They have to keep on colliding with the positively charged particle, and because they collide with the positively charged particle, there is a resistance in the conductor. So this is what the thing is here. What happened here? Resistance depends on interaction between there are three types of interaction actually in a solution: solute. The second one is solvent, 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 solvent. Third is solvent, solute. Solvent and solute. Let me repeat back this particular thing here. What happened there? The resistance is due to the collision between the positively charged particle and electron. But here, the resistance of the electrolytic solution depends on the attractive forces between the solute and solute, solvent and solvent, and solute with solvent. Because the ions have to be free. You need to understand that ions must be free. But what is happening here? There is an attraction. That attraction do not let them to flow freely. So the attraction is the cause of the resistance here. Talk about the fourth point here. No chemical decomposition take place. No chemical decomposition take place but there chemical decomposition takes place. Chemical decomposition takes place. What that mean here? When current passes through the copper wire or any aluminum wire or any metallic wire, there's nothing happening before and after the current has passed through that solid conductor. But what happens when you put some salt into a solution? The salt breaks into ions. So this is like a kind of chemical decomposition. So fifth one is going to be like temperature is inversely proportional to conductance of solid. Temperature is inversely proportional to conductance. Right? What that mean? If you increase the temperature of a conductor, what happen? The electronic collision with the ions increases. So this is like nothing but due to some chaotic situation, in a traffic, many vehicles start colliding. And as the collision proceed, what happen? The flow of traffic is absolutely disturbed. So what is happening? You are increasing the temperature, and due to the increase in temperature, the collision between the electrons and the ions, they are increasing, which disrupt the flow of current, and therefore the conductance decreases here. But there, what happened? That the temperature is directly proportional to conductance. Temperature is directly proportional to conductance. Because, let me write this first, because the heat provided into the solution breaks the interaction between the particle. Interaction between the particles. What particle I am talking? These are some of the particle I am talking. So let me repeat back here. If you increase the temperature, increasing the temperature means you are increasing the heat in the system. So that heat actually break the forces of attraction between solute, between solvent, between solvent and solute. And if the force of attraction decreases, the ions will become free and they will easily move. So there, increasing temperature decrease the conductance, but there the increasing temperature increases the conductance because the force of attraction decreases. Right? I have one more point which I want to add, somewhere here. I am talking about viscosity. Viscosity of the solvent, which is inversely proportional to conductance. Right? I have written it on the wrong side. In this case, sorry for this. In this case, viscosity has no effect. Has no effect. Why? Because a solid doesn't have viscous, solid is not like a liquid. But there, viscosity of solvent is inversely proportional to conductance. Right? So these are some of the factors that decides the conductance of solid and conductance of electrolytic solution. There are more coming up, but I will do that in the next video. And so I must wind this right here. And I would say thanks for watching. And in case you have liked and you want to say something, please do that, because that's what really help me to know what I'm doing actually. So it doesn't matter what you have to say, just start saying that. That's it.